Well, on to part B of this 10-point FRQ. As is true with many FRQs, the later parts have got very little or nothing to do with the earlier parts. So if you have difficulty with the earlier part, don't worry, this could be a whole new show. Let's read it. In another experiment, 0.15 molar, okay, BF4 negative ion, best friends forever with a couple of other F's added, or it's called the tetrafluoroborate anion. So tetrafluoroborate, say that 3 times quickly, is prepared by dissolving sodium tetraborofluorate. This is going to be a tough one to pronounce, in distilled water. The BF4 negative ions in the solution slowly react with water, and the reversible reaction shown below. It's a slower reaction, so they've got it per minute. And interestingly, they are monitoring it by concentration of the hydrofluoric acid that's produced. Here it is. We start with no hydrofluoric acid, and then gradually over, 200. We're talking about hours, 10 hours finally even. We end up getting a certain concentration of the hydrofluoric acid. So that's what's happening. Let's see what the question is. They're clarifying things. The hydrofluoric acid concentration reaches a constant value. Now, that's our second concentration. Our first concentration was 0.15, but that was the tetrafluoroborate ion. And now we're talking about the hydrogen fluoride, the product, when the reaction reaches equilibrium. For the forward reaction, the rate law is rate is equal to Kf just times the concentration of our reactant, first order reaction. The value of the rate constant was experimentally determined to be 9 times 10 to the 4, and they have it per minute. And that's the typical unit that you have for a first order rate constant. Calculate the rate of the forward reaction after 600 minutes. Okay, we've got the equation. They gave it to us here. The rate is equal to the Kf, that's what they've given, times the concentration of the tetrafluoroborate, which we had, but that was the tetrafluoroborate at the very start of the reaction. So we can't use that. I mean, if it's 0 minutes, that's what we would have. But no, this is at 600 minutes. What do we have at 600 minutes? The HF concentration, and we've got the equation. Well, the tetraborofluorate turns into HF 1:1. So if you're clever, you can say, well, I can use that to find the concentration of the tetraborofluorate at 600 minutes. And so you started with 0.15 molar. I got the 0.14 made, so I've got to have that much tetrafluoroborate left over. Now, if that doesn't make sense to you, if you couldn't figure that out, then an ice chart would be warranted. You could say, okay, here's my reaction, here's my initial. I'm starting off with 0.15 molar of my reactant. That's easier to say than tetrafluoroborate. And then at our HF, I know, increases to become 0.0174, so we know what happens in terms of changes. So if you couldn't see this, then the ice chart would make sense to you. But this gives us our answer. You might say this is involved a lot, but actually B was worth 3 points. That's pretty good, so it's worth the time. So now the calculation is relatively easy. In fact, actually, what happens is you got 1 point just for finding the molarity of the BF4. So there's a point right there. Doing the calculation, we would take then our rate constant, which we had 9 times 10 to the negative 4, and multiply it times. Now we know what the concentration of the BF4 is. Calculator time. 9, second function, e raised to the negative 4 times, now this is the 0.133. Of course, if you use the 0.15, your answer would be wrong, and the answer is going to be this 1.20 times 10 to the negative 4. So you get a point for that number. So we have 1 point for the value of the rate. Now notice they said the value of the rate because there's another point. See, here it says include units with your answer. So you would get 1 point for the units. The way this problem is set up, it's a very nice the way they grade these FRQs. They're not as cruel as you might think they are. You get a point for the earned molarity, which was the 0.133 that you had here. But if you had that wrong, so if you lost the point because you had the wrong molarity, and I imagine a lot of people did, if you're rushing, you say, oh, it's 0.15 molar, but not at 600 minutes, you would lose the point for using 0.15. But if you set up the calculation and showed your calculation of 9 times 0.15, they would not penalize you because you were already penalized for that previous point. And you would have gotten the full point value for the answer, even though it was wrong. You would have gotten the grader would say, okay, they multiplied it right, they had a consistent value. So you'd get that point. So all was not lost. And then you get another point for the units, the molar per minute, which is our unit for naturally for rates, which is always molar per minute or second or eon. So out of these 3 points, if you missed this 0.15, you would have still gotten 2. That's like 66%, which is at least a 4 most likely. So don't lose heart in case you get a very beginning question wrong. This is one of the nice things about the FRQs. You're not double penalized for an earlier question. There, we've got 3 points. Well, let's now go on to do C, which will be in the next recording. So go on to the next recording in this series of question number 3.